Welcome. We want to look at another example of an application which uses a quadratic equation. So a company finds that its profits can be modeled with the formula P equals, so profits equals 67.2x minus 4.2x squared, where P is the profit in millions of dollars and X is the number of units produced in thousands. That's not supposed to be thousands of dollars, just in thousands. All right. At what production levels will the profits reach 100 million? In order to answer that question, right, we're looking for profits to be 100 million. So we're looking to solve the profits being 100 million. So 100 is equal to 67.2 times x minus 4.2 times x squared. So we immediately have our quadratic equation that we would like to solve. We'd like to write it as ax squared plus bx plus c is equal to 0, so that we can get a better idea of how we want to approach the problem. I mean, we can probably guess at that now, but we'll do that anyway. So I'm going to add the 4.2 x squared and subtract the 67.2x from both sides. So I still have the 100 on the left, and now I have 0 on the right. Written in this way, we very clearly can identify our value for A, B, and C. Since we don't have integer values for A, B, and C, this is a scenario in which we might recommend using the quadratic formula. Might. Okay. You could certainly still pull out that greatest common factor. Well, potential greatest common factor of 4.2. It's not actually greatest common factor, I don't believe. Let's see here, 100 divided by 4.2. Is it very nice? No, it's not at all. Surprise. Not surprised. All right, so, but you could pull that off and work on completing the square and doing all of that. In this case, I would recommend just using the quadratic formula. So just as a reminder, the quadratic formula says that x is equal to negative b plus or minus the square root of b squared minus 4 times a times c. And this is all divided by 2 times a. So we have values for a, b, and c here because of our quadratic equation. Our quadratic equation. We know that a is equal to 4.2, b is equal to negative 67.2, and that c is equal to 100. So we can plug those values in. So the negative of a negative is a positive, so we have 67.2 plus or minus the square root of b squared is, again, well, in this case, we want to write it as negative 67.2. It wouldn't really matter because we're going to square it, and that would remove the negative, but plugging in actual values is a good idea. Minus 4 times a, which is 4.2, times c, which is 100. That is all underneath the radical here. And we are going to divide by 2 times the a value of 4.2. So you may want to approach this in pieces, evaluating it in your calculator. Maybe you want to approach it by plugging everything all in at once. And I really would encourage you to go ahead, follow through, and plug these in for yourselves and verify that you can get the correct answer of x is equal to. I'm going to give a little bit more precision than is necessary here. So I'm going to write it as 14.339. And actually, it keeps on going a bit there. Keeps on going. Or x is equal to, we'll write it as 1.6604, and that also keeps going. So profits will reach 100 million. Let's see, dollars there, $100 million when production is at approximately We're going to write it as just one decimal place, rounding to the nearest tenth. And the reason that we're going to do that is because of this idea of significant figures. The the numbers in the problem that were given are rounded to the nearest tenth. And well, actually, right, if we wanted to really follow along with the idea of significant figures, there's three significant figures here, two significant figures here, and three significant figures here. Uh, yes. Actually, I think there's technically more than three here because 100 million, we do get all of those other zeros. When is it precisely that, right? But there's only two significant figures here, so we should be working with technically only two significant figures or something of the sort. Anyway, that's a discussion for a different class. I'm not too worried. Let's round it to the nearest tenth just so we can write things down easily. So profits will reach 100 million when production is at approximately 14.3 thousand or 1.7 thousand units. Excellent. And that's all that we were looking for.